we're going to talk about how to use dummy variables in forecasting. As always, you can download this file in our website, and it consists of three tabs. It's exercise tab where we going to do the calculation step by step. Then there is exercise solution tab where the solution is provided for you, as the name would suggest. And then there is a third tab called question when there's a different data set and you're going to do a similar exercise by yourself and then upload it to our website, after which you'll receive the solution for this calculation too, and you can compare and find any potential problems. So let's get to it. We have here sales data from a company called Gift Cards Limited, and as the name suggests, it's a company selling gift cards, and uh, it's their sales in last last how many? Last 20 quarters. And as you would expect from such a company, the data is really seasonal, and we would want to uh, predict the sales for next 4 quarters, so the accounting can use it for its budgeting. And because the data is probably seasonal, you can already kind of see it on the data. Like first quarter almost knows, like there's like a much more less sales than the following quarters. Then the fourth quarter is quite successful and it falls down again, and basically goes like that every year. And if you just use linear like regression, you will probably find out that these quarters are really not so successful as the fourth one, and but like how to actually use it for forecasting if there is a seasonal trend and you can just fit one line in there. So first of all, we're going to plot it. So I'm going to show you, and the seasonal component will be very clear after I do so. So I highlight the sales data. I'm going to not use the scatter box. I'm going to use the trend line because I'm going to use the 2D line because it's going to be a little bit representative of the sales in time. And as you can see already, Uh, the sales really have quite a strong seasonal component. As you know, we've seen it in data, but now it's more apparent. So first of all, let's do some editing to the chart. So I enlarge it a little bit. I click on an axis. I'm going to format the axis by right-clicking on it, and I'm going to change the minimum. I would probably want to change it somewhere to 50,000, because all of the data points are above 50,000 and all this space here is wasted. So 50,000, and that's much better. It's much more representative. Also, even though I have here 2002, 2012, 2013 and so on, and the quarters, here I have just the data point, which is not really so representative. So I'm going to click on the axis, right click, and I'm going to select data, and here it offers me edit just the axis labels. So I'm going to press edit, and I can actually choose both of the components, quarter and the year, and it actually goes straight to the chart. You can see it already. I'm going to enlarge it so it doesn't look so terrible, and it's quite good, isn't it? So we have sales on this axis and the time on this axis. I can also add the 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 titles. So time and sales. Well, for forecasting, I could also display the trend line by right clicking, clicking on the first I want to click on the data points. So I can see that they are selected by because they are highlighted. Right click, add trend line, nice linear trend line, and I choose the linear equation for it. But even though like it's quite irregular, and you can probably see that this linear line doesn't really represent what's happening in the sales, does it? Because, if you use a linear trend line, then, every December you would probably have like a hugely successful sales, and every July, you would show that you are really seriously underperforming, and that's not really in any way representative of what's happening to the company. Just because the sales are actually happening in December doesn't mean that the company is unsuccessful in July. It just doesn't work that way. So this trend line is not really representative of what's happening in there, and you can already see it in quite low R square, even though 0.45 is still like all right, a regression, but we can definitely find a much better one. So what we're going to do is for each of these quarters, we're going to assign a dummy variable. Uh, the rule for assigning dummy variables is that, depending on how many categorical variables you have, you always assign that number minus one dummy variables. So we have 4 quarters. So 4 minus 1 is 3. So we'll have 3 uh, dummy variables. The reason why it's always minus 1 is that, if you assign also a dummy variable to the last one, then the last one wouldn't be independent from the other ones, and the regression would not fulfill one of the crucial conditions of the independence of variables. So we don't want to do that. We will assign only three dummies. So first of all, I'm going to take the sales data over here and insert it into this pre-prepared table I have over here. Then the data point, well, each time is the previous one plus one. So I could start at 2012, but I will start at 1 and just number them plus 1. And now if I just copy this formula down, it just nicely populates the scale. So I go from data point number 1 to data point number 20, and that's going to be one of our depending variables. So we'll have a sales which are independent variable, and data point is the first of dependent variable, and the remaining dependent variables will be the dummies which we are going to assign to the quarters. So the first quarter will be first dummy, which we're going to assign uh, number 1, and if we are going to be in the first quarter, the remaining 2 quarters will be zeros. And if we are going to, this is the second quarter, so like, here we are in the first quarter, so in that quarter, the dummy is 1, the remaining are zeros. We're moving to the second quarter, so this is going to be 1. In third quarter, this is going to be 1. The remaining fields will be filled with zeros. And in fourth quarter, because there is no dummy variable in fourth quarter, it's going to be only zeros. The effect of fourth quarter will be actually included in the intercept, and I'll show you how after we receive the regression, I'll show you how to interpret it. Also, because the fourth quarter is actually always the highest sales, there's a good chance that all of these 3 dummy variables will actually have a negative sign next to them. So we'll see if that really happens after we calculate the regression. Now I can just copy, because now I did the first year, it was the year 2012. I'm going to copy it down, and now I populated the whole table. Again, copying down because it's normal numbers. I just pressed Control I highlighted the first tier, Control C, and I just copied it, Control V to the rest of the table. So this is our data set now prepared for calculation of the regression. We'll use the data analysis tool to calculate the regression. Again, if you go to data and you find out that the data analysis is not here, you have to go to File, Options, Add-ins, Excel add-ins. Make sure that you have Excel add-ins over here. Go and click Analysis Tool Pack and press OK, but I already have it clicked, so it's fine. So go to Data, Data Analysis, choose Regression, and Y variable. So you have to use the sales, which is our Y variable. Highlight it with the label. With the X range, you want to highlight all 4 columns, including labels. So we have all 4 variables are in there, 3 dummies plus the time. We could also check the residuals and residual plots, but we actually don't need to do it right now because I can just tell you they are fine. And this is our regression. As I expected, all the quarters over here are with minus sign because and the effect of the 4th quarter is inside of the intercept. The regression, well, the R square is 0.97 almost, which means that 97% of this this line of the sales can be explained by this equation. Or I can actually write down the equation in a second, so you can compare it with just the linear regression we used here. It was only 0.45. Now we are at 0.96. So definitely much better way how to interpret the sales, and also much better equation to use for forecasting future values. So if I was to write the equation using these coefficients over here, so intercept is 80030.5 plus, I'll be a bit lazy and I'm just going to copy it, quarter 1, quarter 2. I have one more minus sign over here and I need quarter 3 plus time, or data point, or the data point. So this is the equation. So basically any future data point can be calculated. I have even one more minus sign over here, which doesn't have to be there. So every future value of sales can be calculated as the intercept 80,000, and and depending on which quarter we are in, we are going to use one of these 3 numbers. If it's quarter 4, we just don't use any of them, which means that, because all of these quarters, they actually have a negative impact. So if it's quarter 4, we don't going to use any of the quarter slopes, just the time and the intercept, and the number will be of course bigger than any other quarters, exactly as the trend line would suggest. All right, so now if we want to calculate the forecast for 2017, we basically just use this equation, and you can do it manually, which means We are in the first quarter of 2017, so it's the intercept plus quarter one plus the data point times 21. And there was that times didn't take, so once more 21. There's still a mistake in there somewhere. I'm trying to figure out what it is. This uh, data point 55. Here we go. So this is the value. This is the value of sales which we expect to happen in the first quarter of 2017. If you want to copy this formula down, all you have to do is to basically just to fix the fields which you don't want to be changed. So the intercept will stay the same. We want to change the quarter, so the red will stay as it is. We want the data point slope to stay as well, so we'll fix it. And the green, which is over here, we want to actually move down, so we'll leave it as it is. So now if I copy it, and I already know there will be a mistake now, so uh, this one is first quarter of 2017, which means first intercept plus first quarter plus data point time to the data point slope time to data point. The second one is using the second quarter. Third one is using the third quarter, and fourth one, and that's the mistake I was talking about. It uses the data point twice, which is indeed wrong, so I'll fix it. And that's the that's the value of the sales in 2000 in 2017. I'll just quickly check against the results I have here in solution, and indeed it's the same. So it's perfect. So thank you very much for your attention. After you complete this calculation, just go to question and uh, please replicate the calculation which you just learned on this yet another data set and upload it to our website, after which you'll receive the solution for it so you can check it against it. So once again, thank you very much and see you next video.